Hello and welcome to my webinar, Creating iOS Apps Using Delphi XE2. My name is Anders Olsen. I'm a staff engineer here at Embarcadero Technologies, and I'm in developer relations. So let's get started. I'm going to cover a few things that have come up lately, which is setting up and getting ready for iOS development. We'll start off with that first. And one thing that comes up often is which version of Xcode should I have installed, 4.2 or 4.3? And the answer is typically both, because Xcode 4.3 enables you to target iOS 5.1 and higher, and Xcode 4.2 enables you to target 5.0 and prior. The problem is that Xcode 4.3 requires Lion. So if you only have Snow Leopard, then you will not be able to target 5.1 and higher. If you don't need to, of course, you're fine. You can just install Xcode 4.2 for Snow Leopard and then install Free Pascal and FireMonkey for iOS. Both of those are in the FireMonkey underbar iOS DMG file. If you do have Lion, then my recommendation is that you install Xcode 4.2 for Lion first. Then you install Free Pascal and FMI, just like in the Snow Leopard case. Finally, you install Xcode 4.3 and make sure to say no when it asks about uninstalling Xcode 4.2. because it will remove the entire developer directory, and which of course is where FPC and FMI are installed. So you'll have to start over again and uninstall 4.3 and 4.2 and then start over with doing it the correct way, which is installing 4.2 first, then FPC, FMI, and finally F4.3 without uninstalling 4.2. And this is, of course, all on the Macintosh side of things. You do need a Macintosh in order to develop for iOS. Finally, on the Windows side, of course, you install Rad Studio XE2 or Delphi XE2, depending on what you have. So in my case, for instance, as we can see here, I have a MacBook Pro with 8 gigs of RAM in this case. I'm using Xcode 4.3, but I do have 4.2 installed as well. And we can actually see that in the launch pad here. You'll see that we have multiple Xcode icons. Okay, so today we're going to talk a lot about using my components, and we're going to talk about making applications that use multiple forms. We're going to talk about scaling forms so that you can design for the iPad, but also run on the iPhone and have the forms show up as full screen on both. So if we start with my iOS components that I've built for both iPhone and iPad here. If you haven't downloaded them yet, you can feel free to do so at your leisure. It's item 28635 in Code Central. I've got 13 components here and a few simple demos. The components include a custom T-switch that has custom on and off labels. So you can say on, off, or you can say yes, no, or you can say whatever you want to put on them. You can localize them, etc. I have a pinch gesture recognizer that recognizes the native pinch and zoom gesture. I have a rotation gesture recognizer that recognizes rotation gestures, so you can use both fingers to rotate an object. Swipe gesture recognizer that recognizes up, down, left, and right swipes. The accelerometer component gives you the X, Y, and Z acceleration, or tilt, if you will. TiOS gauge is simply a round gauge that is a very simple gauge that allows you to show values on a gauge. For instance, use it for making a compass, or use it for making a speedometer. We'll see examples of both today. iOS location, both GPS and compass is available. Reverse geocoder for translating a latitude-longitude pair into an address, if possible. And finally, 5 components for shared application stuff. Icon badge is for setting the numbers on the little icon for number of notifications, number of emails, etc., or whatever your application wants to tell you. Email to send an email using the Mail app. Map to get directions via the Maps app. URL for opening a custom URL in Safari. And phone for dialing a phone number with a phone app. Okay, so that's item 28635. Another thing that I want to mention is if you're starting from absolute scratch, you should really check out this e-learning series, Getting Started with FireMonkey, that David I is putting on. Chapter 1 especially covers a lot of the setup things that you need. So he goes into more detail than what I'm doing as far as with the setting up Xcode and those kind of things. And I'm posting everything on my blog as I develop more things or come up with more demos and things like that. The other thing that I want to show you real quick is we're going to use another application today, which is Reflection. I have Reflection installed on my Mac. It's when I bought it, it was $15. What it does is it enables me to mirror the iPad on the Macintosh. So as soon as I turn on AirPlay, I can see my iPad screen. And you just do it from the AirPlay here. You see my Mac is down here, right here, and I turn on the mirroring. And what it enables me to do is simply see the screen of the iPad so that I can run all my applications on the screen here. And in this case, see what time it is, all these kind of things. Okay. The other thing, it does support rotation events too, which is very cool. So let's turn that off for now. All right, so let's go back here. So you download the components, you install it into the IDE, the package, and what that will look like is once you have a project on the screen, an iOS project in particular, so create a FireMonkey iOS application here. If you filter on iOS, you'll see my iOS tab. So you'll see the TiOS icon badge, email map, URL, etc. All these components here. And then the whole point, of course, is that the accelerometer, for instance, has the built-in support for what the accelerometer does. So it will give you an event on Accelerate. If you double-click on it, you'll see that you get X, Y, and Z values. It's turned on by default. You can turn it off whenever you don't need accelerometer events, and then turn it on again. You can set the update interval or whatever you want. This is in Hertz. And of course, if we take a look at what the actual source code looks like, so the whole point of course, making components is that so you can just drag and drop and use them, right? And it also insulates you from all the Free Pascal stuff that we have to do, all the custom glue for getting to these things. So at the beginning here, we'll see a couple of switches here that tells the Free Pascal compiler is going to be in Delphi mode, and use also Objective-C, which is, oops, turn those off. Okay, we use the iPhone all unit. The reason I have these if-defs is that so that will actually compile on Windows, so you can test your UI. Of course, this application doesn't do anything on Windows because it uses an accelerometer component, which Windows doesn't have. Okay, I declare a few things. We have a t-accelerate event that we use then for the on-accelerate to get our X, Y, and Z components. This is very much like the on-click event or whatever that you'll see if you look in other FireMonkey units for Delphi. The accelerometer component itself simply surfaces the on-accelerate. It surfaces the update interval. It has the enable property. They're surfaced right here as properties, right? We have a constructor and we have a destructor. Then we have an internal variable for acceleration. We get a timestamp. We don't necessarily have to pass that on, but it has to be declared in here. Then we have the X, Y, and Z. This is what it looks like on the Objective-C layer. Then we have a delegate. This is the procedure. Accelerometer did accelerate, and it passes this Objective-C type. Both the actual instance of the accelerometer and the acceleration message. Okay, we declare a variable which is of that type, the delegate. In my case, I declare a global accelerometer because I assume that you're not going to need more than one. You can have a global one. The implementation in the whenever we get the accelerate event, we will, on the Objective-C side, we will surface the same event on the Delphi side, but in this case, the component event that we're looking for. So if we have an assigned accelerometer and we have a on-accelerate event assigned on that, we go ahead and call it and pass with the acceleration X, Y, and Z. In the constructor, it simply makes sure that we only have one. So if we already have one, it says it won't let you create more than one. We allocate the delegate. We set default values, update interval, and enable to true. And we assign the global accelerometer to self. When we destroy it, we simply get rid of it, and we release the delegate. Setting it to enabled or disabled is simply a matter of hooking this delegate up or taking it away. And setting the update interval is a matter of calling the shared accelerometer and setting the update interval. Okay? So as far as using the component, once you have it installed, it's very easy to just drag and drop and hook it up and do whatever you need to. If you double click on here, you'll get the acceleration event and you can start dealing with it. And very much the same goes for all of the other components. If we take a look at a swipe gesture recognizer, for instance, I'm surfacing an event here, actually 4 events on swipe down, swipe left, swipe right, and swipe up. And when we double click on it, we just get an event handler on the Delphi side that we implement and do whatever we need to. If we actually go and if we close this and we open up the iOS comps dproj, which is the first thing you're going to do when you install it, when you download it and install it, you'll open this and you'll go ahead and click install here. If you had an older version, you uninstall it and you install it again and make sure it builds the newer version. You'll see that it has the accelerometer unit, which has the accelerometer component in it. We got the gauge that has the iOS gauge in it. Location has the GPS, and the reverse geocoder is in this file. The pinch and zoom gesture recognizer is in here. The rotation gesture recognizer is in the rotator.pass. Shared application has the email, the URL, and those things. Swiper we just looked at. That's the swipe gesture recognizer. And switchy.pass is just my custom T-switch that adds the custom labels. We'll see examples of most of these components in this webinar today. The thing that you do need to do, of course, you install the component package on Windows in RAD Studio or in Delphi XE2. That enables Delphi to see the components at design time as well as runtime when you're testing on Win32. In order to get it to work at runtime, the files have to be accessible to the Free Pascal compiler that's being called upon by Xcode when you're building the project and actually building the iOS project. So if you use my switch component, or if you use the reverse geocoder, et cetera, you have to deploy the relevant files, accelerometer.pass or whatever, to the Xcode folder. So if we take a look at a project here, FMX- for instance. So if I open that up here, this is simply a little application that will test a few different things. I have a gauge here. This is a speedometer, TiOS gauge. The compass is actually not a gauge. It's a T-circle with a compass needle in it, which is a circle in the middle and two rectangles that are parented in here. So as we turn the compass needle, the circle in the middle, the both needles will turn as well. And then we have 4 labels, one for northwest, east, and south in here. Then these are just labels that are going to display heading, latitude, longitude, altitude, speed, and course. The memo in the middle here will display the address, if possible. The tilt gauges at the bottom, these are iOS gauges, like this. So we have X, Y, and Z here. Okay, so let's take a look at it. So accelerometer, when we get an acceleration event, we're just going to change the value of the gauges. Tilt gauge X, Y, and Z gets 90 times the value of X, Y, and Z. X, Y, and Z, by the way, are in the range of plus minus 1. So minimum is -1 and maximum is +1. That's why the gauges go between plus minus 90 here. We got 0 up here, plus 45, 90, and this serves as doubles as plus minus 90 actually. iOS location, when we get a update heading event for the compass, we set the rotation angle of the compass needle, and we display the heading and accuracy as the text label. When we get a location update, we set the speedometer value, and we update all those text elements. So we set the latitude, set the longitude, set the altitude. We set the speed as a numeric value. We set the course. And the last thing we do when we get a location update, we have to, if we want to, we have to feed those values, the latitude and longitude, to the reverse geocoder. The reverse geocoder is then executed and an event comes back. 2 events can come back. An error, in that case, we just display not available or not applicable. If we found a place mark, this is the name of the event on the iOS side, I just keep it the same. So if we get something, then we add to the memo, we just add the address, the city, the state, and the country. Okay, so let's go run that on iOS. So if we open up FMX-, let's go ahead and run it on the simulator first. So here it is on the iPhone simulator. We're going to run it here. I'm going to compile and build. Simulator is going to come up. There it is. The application is launching. And here we can see that location is actually changing here. Here under the debug menu, there's a location which we can simulate. So now we don't get any location updates. If we set freeway drive here, it'll start from 0, and you'll see the speedometer actually works here. We get location updates. We don't get a heading because we don't have anything simulating compass. But we do get location updates. Doesn't necessarily give us the correct altitude either, but it does give us speed and course. And the reverse geocoder is working. We get address updates here as we're going. It's going about 60 miles an hour right now. We don't get acceleration events, accelerometer events either, because there's nothing simulating those. Okay, now he's actually going to get a ticket probably. Going to get up to about 80 miles an hour here, and then he's probably getting pulled over because he slows down pretty soon. So here's he gets pulled over. So anyway, we'll close the application here, and we'll go ahead and run it on the iPad simulator, see what it looks like there. And here we'll notice that it's not going to take the full screen. It's only going to be visible on a quarter of the screen. We get the same simulated route here every time we run it, which is kind of cool because it allows you to debug. So let's fix this problem, and let's make sure that we can actually cover the whole screen here as intended. So one way of doing that fairly quickly is to drop down a scaled layout. So if we drop down a scaled layout here and make sure that it takes the client space, and then of course we have to drop all these components in there as well. So let's go ahead and do that. We're going to take all of these, we're going to drop them onto the scaled layout, and we're going to take all of these, put them on there as well. And finally these. We save that, and you'll notice in my case I use the shared directory that we had that I showed you before. So it's under my Z drive, and it's in the FMX dash directory, which is exactly where Xcode is going to look for the project. So when I go back here and simply rebuild it, it will come up on the iPad in full screen. It's not necessarily the best. We can set the align to, instead of AL client, we can set it to fit so that we actually get circles instead of more elliptical views here. But we do get an application that scales between the iPad and the iPhone. So just going back to the iPhone here and running it, will show you that it actually still works on the iPhone. Right? A side effect here is that if we rotate to the left, it'll scale to fit this as well. Now, this isn't necessarily the best, like I said earlier, either. But you can experiment with different alignments, and you can even treat different rotations differently if you want to. Speaking of which, if we take a short segue here and go to my blog, we're going to find this post right here. Some of my components take advantage of a couple of things that are hidden or in the implementation section, rather, of the iOS platform file, the FMX underbar platform underbar iOS .pass file. And what I've done there is I have moved the UI view controller declaration and the UI window declaration to the interface section instead of being in the implementation section. I've also moved main window as a variable to the interface section instead of the implementation section. I've declared 5 global variables in the interface section, current orientation, and then a couple, 4 different supporting variables: supports portrait, supports upside down portrait, supports right and left landscape. Finally, in the implementation section, this is the UI controller should auto rotate to interface orientation. We simply use the, if I go over here, we use these supports landscape, right, left, portrait, and upside down portrait, or portrait upside down, to define whether or not we are going to let it rotate. If we let it rotate, then we update the current rotation as well. So once you make these changes to that file on your Macintosh side, we can actually start using those. So let's take a look and see what this actually looks like on the device. So I'm going to turn on the mirroring again using reflection. And I'm going to run it on this iPad. So we do it clean and we run it. It's going to build it. And it's going to deploy it to the iPad. Should say build succeeded. There we go. Sandboxing and running the application. And there's the application. You can see the location icon popped up here alongside the AirPlay one. Okay, you can see that the compass is working. I'm turning my iPad in front of me, just turning it a little bit, and you'll see the compass needle. Okay, I can't demonstrate the speedometer here, but you saw that working in Xcode. You do see the heading modify. You do see the altitude, 620 feet, plus minus 33. Not sure why the speed says -2. It's not reliable if it's negative anyway. And for some reason, I'm not getting an address back from my reverse geocoder. Sometimes it takes a while for that to initialize. Yeah, there we go. For some reason, it takes a while to get those events. Anyway, you'll see the tilt gauges or the accelerometer gauges. I'm turning this thing in front of me all kinds of different directions. You see the values. If I tilt it forward, you see the tilt Y. If I tilt it sideways, you see the tilt X. If I throw it up or drop it, you see the tilt Z react. All right. So let's go to our next demo here. Let's take a look at my acceleration demo. This is also in Code Central. I have it right here. So this is a little game. Running it on Windows won't do anything because it takes advantage of the accelerometer, so the ball isn't going to move, or the planet isn't going to move. And we're going to open it on in Xcode. We go ahead and run it first on the simulator on the phone. You notice that nothing happens. There's no accelerometer events happening on the simulator. Let's go ahead and run it on the device. There's reflection. Okay, you see the ball's moving. So I'm going to pull this up in front of me and ever so gently tilt the iPad so that I can get the planet Earth to go into the black hole here. Very finicky. There's a pool ball. There's the Embarcadero logo. There's a golf ball. And there's the Delphi icon and back to Earth again. you'll see the score updates in the whole. So anyway, this little demo is on Code Central as well. If you search on my name, you'll find all my demos there. Okay, so very simple example of showing what the accelerometer can do in a simple little game like that. So let's go ahead and continue. You may have seen MathViz, both on Macintosh, Windows, both Delphi and C++ versions. I have articles on implementing my mathematical function visualizer on the EDN. I've updated the iPad version and the iPhone version, the iOS version rather. It's actually free now, and it'll be free probably forever. It's in the App Store, and I can show you if I search for, in this case, MathViz. Oh, look, it's even a common search result. And there it is, right here. Okay, so it says here May 14th, I added zoom and pinch rotation support. We can run it, see what it does. Oh, it was already running. So let's actually terminate it and start from scratch. So that's what it looks like when you start it. You pick a function. You can use rotation. I'm clicking, tapping on it, or rotating the graphic. You can zoom in and out. So using the pinch, zoom and pinch gestures like this. We can click on it. We can rotate, spin, various directions. You keep spinning if you want. You can turn off the grids. Turn it back so we can see it. We can reset the orientation. We can have different mathematical functions in here. Okay. Essentially, what I added from the Mac and Windows version is I added these gestures, and of course, I added the T switch here, so you can have on and off states. But the pinch gesture recognizer, just like I mentioned earlier, what I do is I get the scale, and I simply set the zoom value to the scale, multiplied by the value. Likewise, when I rotate, when I get a rotation gesture, I simply change, in this case, an arc dial, which I already had on the UI, to do the same thing, this arc dial here. So this arc dial change, when I change the arc dial, it updates the rotation angle for the Z value. So that's really all it takes to, in order to use these components. Okay, now let's talk about my EDN. It's still not in the App Store. I need to add features that can't be done in a web page. So probably something location-based in the future. And then everybody can get my EDN and use it on their iPhones. So let's take a look at my EDN if you haven't seen it before. So here we go. My EDN is right here. So this is designed for the iPhone, but I use scaled layouts and things like that in a scroll box so that it can scale properly on the iPad. This has multiple forms, and it is a data snap client. So in this case, it's talking to the mobile data snap connector. I've imported generated the client proxy for membership services, members.embarcadero.com. So DS proxy here is generated automatically by the proxy generator. We have a lot of functions in here. The ones that we're going to be using in this application is we're going to use update contact to update contact information. We're going to be using get user info to get user information for a specific user. We're going to get registrations, which is the same, registered products. We're going to use get login info, and we're going to be using login. So login, we pass a login name and a password, and we get back a cookie. And that cookie we then pass to all the other functions to validate, to do session validation. And we also have a logout function that we're going to be using. The rest of the UI is really, username, password. We're going to have a username and a password edit box. We're going to have whether or not we want to store usernames. We have a switch that takes care of that. Whenever we change the switch here, we determine whether or not we're going to save credentials. Save credentials uses SQLite. Since we're only keeping track of one user and one password, plus the setting of that button, we drop the table and create the table. So we lose any other information that we had before. So all you need to do if you want to lend your iOS device to somebody else, but you don't want them to have your credentials in a file at all, you can simply turn that switch off and it immediately drops the table. And if we turn the switch on, we save the credentials, of course. So we drop the old one, create a new one, and then we create, we insert a new value, insert into users values, and we pass the username, we pass the password, and we pass the value of the stored button. Right there, we execute this the query. When we start up, we load the credentials. So if we had existing credentials, we simply load them from the SQL. We extract the username, the password, and the state of the button. We free the proxy. We can log in simply by creating a proxy, calling login, passing username and password. We get a cookie back, depending on whether it's a good cookie or not. We set different values, whether we succeeded or not. Logout simply calls the function logout. Login will call login with the username and password, and we get the login name back. We get the user information, so we get the rest of the user information like email, company name, salutation, title, language, etc., etc. And we set that up in an internal user variable. And then we create the main form. So this is how I deal with creating new forms. I simply create the new forms and show them on top of the other one. It's not like Windows where you have multiple windows are going to overlap and be offset in relation to each other. You're only going to be showing, most of the time, you're only going to be showing one form at a time, and they're going to be full screen. So in reality, the old form is actually behind this form that gets created. So we set up the greeting text, the user text. We set the width and the height. And we turn turn off the login form. That's the current one, and we turn on the main form. The only exception to having multiple forms that are visible at the same time would be if you put up a dialog that asks for some input and it's small enough to be visible at the same time. Typically, you don't necessarily do that on iOS, but I did that in the custom edit box on MathViz. For instance, when you put in your custom formula, you get a small little dialog box in the middle of the form, just to show that it works, really. Okay, so that's how we show the next form. And that's the main form. So the main form is going to look like this. So we have the same header. We have the same info button here. The info button, by the way, just shows the info form, which looks like this, about this app, and just has an OK button here. The main form will have buttons for my registered products, my account information, my duplicate accounts, and here underneath here it says my contact information. And then we have a log off button. It also tells you what you're logged in as, who you're logged in as. If you log in as an email address, but you actually have a valid username other than your email address, it'll tell you that here as well. So, and then we have multiple forms for each different thing here. So product form, it will show you how my registered products, last name, first name, email, title, company, my account information, your contact information, or your contact preferences rather. If you want to see emails from us when we launch new products, EDN newsletters, etc. And finally, the duplicate account. If you have duplicate accounts, it'll show up here as well. Okay, so let's run this on a device. My EDN. So we bring up my EDN. Okay, you'll see here that I have icons for EDN put in. You have to generate these icons and load them up in here in Xcode. So let's go ahead and run this on the iPad. Okay, so I have a test username and a password here. I have saved it already. You can toggle this off and on and off. It'll drag, terminate the drop the table, etc. Right? I have I forgot my password. It will send me a password reminder to the email on file. If I log in, it will make a connection to members.embarcadero.com. It'll find out, oh, he's Johnny Appleseed, and the username is Apple Test. I can click on my registered products. I actually have a interbase license here. It doesn't matter that you see the serial number. It's only a one-user registration, so it'll fail if you try to register that. My account information, I just see my last name as Appleseed. My first name is Johnny. My email address is something invalid in this case, appletest@embt.com. My job title, my company. I can go ahead and edit these. I can change it to just Apple if I wanted to. I'm going to save the changes. It'll go back and save the changes on the server. My contact preferences, of course, I would like to see all of the notifications of products, services, and special offers, and I want to see David I's EDN newsletter via email as well. If I toggle these, then the Save Changes button comes up. Duplicate accounts, if I had any, would show up here. It'll tell me I'm logged in as this guy. Apple Test is this user ID. And if I had multiples on the same email address, which shouldn't necessarily be possible anymore, but in some cases it does happen, then you will see the whole list. Click Done, and that's all it does for now. I log off, and I'm back to the login screen. Oh, and the info screen, of course. When I click on the info screen, it'll show up my info screen. All right, so that's a quick overview of my EDN. If you're interested in writing DataSnap clients for iOS, I highly recommend going here to my blog and looking at some DataSnap articles. Writing a DataSnap server and iOS client in 10 minutes flat. This is a very simple and short overview of how to create a DataSnap server and run it, and also create the iOS client. And run it. So why don't we take a quick look at that as well? So still haven't renamed it, but if I bring up my fish project, I'm actually not using fish anymore. But if I look on the client here, In design time, it just looks like this, and all it does is load a bunch of data. We open a connection. We get a data set. We keep timing and stuff like that available. And then we get a data set back. Okay, so and then we use, as usual, do while not dataset dot end of file. We loop through it and we create items in a tree view item. We load blobs outside of it, and we display those. Get data set simply retries a bunch of times, up to 5 times. Get blob does the same thing. So what this looks like is we go to Xcode, and we bring up this fish client. We can run it on the simulator, and it talks to a server that I have deployed in the cloud. And as soon as it launches, it will start downloading the data from the data snap server. So in this case, I get products instead of fish. Right? I can scroll up and see what happens. So that took 4.5 seconds to do it here on the Mac using the simulator. If I run it on the device, I can deploy it to the device. Notice it doesn't exist from before. So the fish server or the fish client will be transferred over. There's the fish client. You saw the icon very briefly. And it will start downloading. If I close it, you notice the fish client got deployed and showed up here. Okay, so the last thing we're going to do here, we're actually going to deploy something to the iOS App Store. Well, let me show you what the clock looks like right now. So this is in the App Store. You can find it by searching for Anders Analog Clock. It only supports iPhone, so it's an iPhone application here that runs on the iPad. If I hit the 2x button, you'll see that it expands and you get twice as large, right? So a very simple iPhone application. You can pick a face here, whichever clock face you want for the application. You can turn on Smooth Drive, and it looks like a Rolex, kind of. Notice the difference from the step function. Okay, so that's the older version. So what I did was I updated it to the new iPad, to Retina graphics. Right. So not necessarily throughout. I added a clock face that is Retina. I added different icons here that are Retina resolution. The splash screens are Retina resolution. The custom clock faces are not necessarily Retina yet, but if we go to the IDE here, close this and bring up Analog Clock, it's designed for the iPad 3. Previously, it was designed for the iPhone. So we're going to use a scaled layout to bring it down to iPhone size when we need to. This, as you can tell, is a high-resolution graphic background. The flame is high-resolution as well. The way it looks, if I run it on the device, you use reflection to look at it. And now you can see that it is, in fact, a high-resolution application. It no longer has the 1x, 2x button down here. We can select and pick the flame. So there's the flame second hand instead of a regular second hand. So now what we're going to do is we're going to deploy this to the App Store. Since it already exists in the App Store, what I'm going to do actually is submit an update. Notice that I have MathViz in here. I've tried submitting my EDN. It hasn't succeeded yet. This is a test app that doesn't do anything. Anders Analog Clock is what we're going to be looking at. So here, This one is existing since October 27th last year. We're going to go ahead and add a version. We're going to call it 1.0. And by the way, I probably will run into some errors here. So bear with me through the process here. What's new in this version? Added support for the new iPad with Retina graphics. Added support for the FireMonkey Flame as the second hand. Hit save. Okay. So here we go. So when I first created this, of course, I gave it a name, called it analog clock, right? I specified, copyright, and I specified a bunch of metadata. In this case, we would like to edit the metadata and see what it looks like. Yep, analog clock watch. I'm going to add FireMonkey as a keyword. Okay, and this is good. These are all good. I'm going to need an iPad screenshot. So the way we can do that is go to Xcode. You run it on the iPad simulator. There it is. I'm going to, let's put the flame on there. Okay. And we go ahead and take a screenshot. Screenshot, save screenshot. It saves it on the desktop. And we choose the file. So it created a screenshot here today at 10:47, which is right now when I'm recording this. We choose it. It's going to upload it. And there's my iPad screenshot. This is required since this is going to be an iPad application as well, a universal application. We save it. I think that's all I need to do. I don't believe I have to specify any particular things here. Oh yeah, ratings and stuff like that. Those are, of course, there's nothing there. Oh, there we go. I can choose a new large icon for my application. Oh, there we go, clock 512. Let's choose that and upload that instead. It's going to be a Retina version. There we go. We save that. Much better looking. Maybe. We can update the copyright. Make it like that. Save it. So we're going to go ahead and say ready to upload binary. Have you added any added or made changes to encryption features since you last submitted? No. Are you updating this app because of legal issues? No. Continue. And here we get to choose whether or not it will be automatically available once it's approved. You're going to say yes. Or you can release it yourself on your own schedule after it's been approved. It takes about a week to go through the approval process, I believe. Okay, now it says waiting for upload. Okay, so now we need to go to Xcode and actually submit this application. So the way we do that is we need to build it for device. And we go in and say archive. Oh, one thing we need to do is update the version number to 1.1. It's universal, so it's going to be an iPad application. It updated the bundle version to 1.1 right here. The bundle ID needs to be com.andersolsen.analogclock.01. So I need to go into Xcode and I need to specify that here. com.andersolsen. Product name is analog clock, which is shown up here, .01. Now it's custom, right? And then we do a archive. It's going to build it, it's going to compress it, and it's going to open the wizard where you submit it. Okay, there's my archive. I'm going to validate this guy. Okay, validate. Hit next. Here, analog clock 11 iOS. Code signing identity is myself. Click next. It's going to upload it. It's going to validate the application. Hopefully we don't get any errors here during the automatic validation on the server side here. Okay, no issues. Excellent. So we can go ahead and distribute this now. I'm going to submit it to the App Store. Much of the same thing is going to happen here. It's going to do validation. And it's going to upload it. There, it's uploaded. We hit finish. We can exit out of here. And we can take a look at the status here. It still says waiting for upload here, but if we go and click on it again. Oh, notice analog clock. There's a 1-1 here. Yellow state. Upload received. Okay, that's a good thing. It's still actually doing validation on the server side. This usually takes a little bit of time, not too long, depending if they find an issue or not. Oh, there we go. Waiting for review. Perfect. So now, on or around June 12th, hopefully, next week, it will be reviewed and hopefully pass. And then you can download the new version. Okay, there we go. So that is it. We submitted it to the App Store. A couple reminders, resources, if you will. My 13 components for iOS in this URL right here. You can download that and play with it to your heart's content. My blog right here, where you'll find everything that I'm working on, playing with. And that's it. Hopefully you enjoyed this webinar, and we will now go to Q&A. Thank you very much.